A number of people were asked how many days they would wait to seek medical treatment if they were suffering pain that interfered with their ability to work. The results are presented in the following table. So if you look at this table, over here in the left column we have the number of days. So that represents the number of days that people would wait to seek medical treatment if they were suffering pain that interfered with their ability to work. And over on this column, the right hand column, we have the frequency. That is how many people reported this fact right here, that they would wait 0 days. So for instance, 27 people said that they would wait 0 days. 1,038 people said that they would wait 1 day. 372 people said they would wait for 2 days, and so on. Consider this collection of people to be a population. Let X be the number of days for a person sampled at random from this population. And what we want to do is to compute the mean of X. So to compute the mean of X, you really can't do it using the frequencies. What you would need are the probabilities of each of these things right here. What's the probability that for if you picked a person at random that they reported 0 days? So to do that by hand, what you would have to do is total all these up and get the total, and then divide each of the frequencies by the total to get the probabilities for each of those things. And then once you had the probabilities, then you would multiply them times the number of days and add all that stuff up. So, but in this video, really we want to talk about how to do this using the TI84. So what you would do is, the very first thing would go into just click Stat, right? And then once you're in Stat, here we're under the Edit menu here, we would click Edit. We would want to go to Edit. So just click Enter there. And that allows you to edit the lists L1 and L2. So what we're going to do in here is just make a little copy of this table over here. So the first entry in there is just going to be 0. Alright, and then we're going to hit Enter, and then 1, then 2, then 3, then 4, then 5. So we just went and made a little copy of these numbers here in L1. Then we're going to do the same thing for the second column, placing those numbers in L2. So 27, 1,038, 372, 272, 19, and 10. Okay. Alright, so now we've got our lists in there, and just double checking everything, it looks good. Alright, so this is just a little copy of this table right in here. So once you get those entered in, then go back to Stat, and what we want to do is use the arrow key over here to tab over to Calc, and then we want one variable stat. So there's no need to scroll down or anything like that, but if you needed to, you would use these up and down arrow keys here. So we want one variable stats. Click Enter to go into that little menu. Okay, and then we get this these three things in here. So list, right, that is where the variable that you're interested in goes. So we put that into L1. That would be 0, 1, 2, 3, 4, 5 over here. And then down here they want frequency list. That would be the list of all the frequencies. And so you can see that's what we put into list number 2. So what we need to do is to tell it where those frequencies are. They're in list 2. So now you would go into second and Stat. That will give you the little list menu there in blue. And then we just scroll down using the arrow keys to the list that we want. We want list 2, and we're under the names thing here. Click Enter. Okay. Okay, so now everything is set up as we want it in one variable stats. The list is in L1, the frequency list is in L2. So we scroll down to calculate and then click enter. And that tells us a lot of stuff about this distribution here. And the one that we want in particular is X bar, the mean, right? So to 2 decimal places, that would be 1.57. There's also a lot of other information that you could get from that. The sum of the x's, sum of the x squareds, the sample, standard deviation, population standard deviation, and that's the total. If you total up all the numbers in this list, it would come up to 1,738. So we could use that to find the probabilities also. If you scroll down, you can get more information. The min, that's the smallest value, which is 0, right? And then it gives us the quartiles, median, and the max 5. So there's a bunch of information that you can get. For this problem, all they really wanted was the mean. So the 2 decimal places, that would be 1.57.